Greetings, mathematician. We are going to do the solutions to Happy Holiday Maths number 12. Starting off with a bit of core 1, sketching a cubic. So part A, factorise completely that thing. Okay, well the first thing I notice is there's an x in every single term, so I'm going to take an x out. So we've got an x out of the brackets, leaving us with an x squared minus 6x plus 9 inside the brackets. And now it just remains to factorise that quadratic, and that's a nice straightforward one. I'm looking at the 9, 3 times 3, and so it's minus 3 times minus 3. There we go. And that's 3 easy marks. In an exam, I would probably, if I had time, I would almost certainly check by multiplying that out. I'd be very paranoid. Now, part B. Sketch the curve with equation, and they've given us this equation, and notice it's the same thing that we had up here. And that's important because this is a structured question. They didn't make you factorise it for no reason. They made you factorise it because it's a lot. Well, you need to factorise it before you can sketch it. So, what does it look like? Well, let's draw some axes. It's a positive cubic, that's the first thing. There we go. And you should know that that means it's going to be that sort of shape. And it's going to have the roots of the equation. Well, we've got x equals 0, that's this one. And then we've got a repeated root at x equals 3. So there's the 3 there. So we draw ourselves a 3 up here. And we put a 0 on. And the cubic is going to come down. And it's going to touch there, that's the repeated root, and then it's going to come down there. And we put the coordinates on because it's asked us to, so that's 0, 0. And that one is 3 along, 0 up. And that's 4 marks for that piece of distilled knowledge. Now, using your answer to part B, big hint here, a big time-saving hint, sketch on a separate diagram the curve with this equation. So it's got something to do with the part B thing. And what I'm going to do, I'm just going to write down the equation from the last part. So it's y equals x cubed minus 6x squared plus 9x. And I don't know if you noticed this, but if you see, you've got the x cubed matching up to this thing cubed, and we've got the 6x squared matching up to 6 times this thing squared, and then the 9x. So this is a graph transformation, and if this is f of x up here, then we are being asked to sketch f of x minus 2, because that's what the x has turned into. So what that means, that is a translation of 2 in the positive x direction. Okay, so that should be pretty straightforward. So we just draw ourselves a graph, and instead of crossing at 0, 0, it's going to cross at 2, 0, 2 along 0 up. And instead of having the repeated root at 3 along 0 up, it's going to be 5 along 0 up. And the whole thing is just going to be moved along. There's our repeated root, and then there's our intercept there. And we don't need to worry about the y-intercept because the question doesn't ask for it. It just wants the x-intercepts. However, if we were going to get it, then it's quite easy to find it. You just have to multiply this out and to look for the constant. So that is our curve sketching question. Now, onto this bad boy. Piece of pie. A lovely juicy piece of pie. It's got radians in it, it's got a sector in it, all sorts of stuff going on here. So let's see what they want us to do first. Okay, so show that the surface area of the box is given by this thing. Okay, so we want surface area. So that means we need to consider all of the faces first. So let's just do that up here where we can draw it next to the shape. So we've got, first of all, we've got this shape here, 1 radian, and that's R, and we've got 2 of those. And then we've got that's the top and the bottom, and then we've got this side face here. That's pretty easy. That's a rectangle, and it's h by r, and we've got two of those as well. And then we've got this curved face here, which if you unwrap it would make a rectangle, and it's h. And depending on how knowledgeable you are about radians, this is the arc length here. So there's a shortcut here if you know your stuff about radians, but we'll just stick with saying that this is the arc length. Right, so let's work out the area of the top. So the area of this is equal to, now you can use the formula if you're a formula member. What I think about it as, I think it's 1, that's the angle, out of 2 pi, because the whole circle, so that's the number of radians in a circle. So this is our fraction of the circle, and then it's times pi r squared, because that's the area of the whole circle. So you can see the pi's cancel, and we're left with r squared over 2. So that's the area of the top. Okay, now this one here, this is easier. The area is clearly h times r. Alright. Now the arc length, well, same as before really, it's a fraction of a whole circle, isn't it? And it's 1 radian out of a possible 2 pi radians, so that's the fraction that it is, and this time it's a fraction of the circumference, which is 2 pi r. And you can see that the 2's cancel, the pi's cancel, and we're left with r. So the arc length is r, which of course actually is what the definition of a radian is. It's the angle swept out by a single radius. So that's r, so the area of this is h times r. Right, so surface area is equal to all this lot added up. So it's r squared over 2, add another r squared over 2, add 2 HRs, that's the top and the bottom, add another HR, that's the curved surface, and that comes to, so 2 of those come to r squared plus 3HR. So let's go down and see how that ties in. So surface area is equal to r squared plus 3HR. Doesn't look very much like this, does it? What's the big difference? Well, it's this h business. So we've got to have some way of getting rid of h. We've got the r squared. We've got, well, we haven't got the over r, or this whole bit isn't here yet. So possibly a little confusing. Let's just go back and see what information we haven't used yet. So we've obviously used everything in the diagram, but we haven't used this bit of information yet. So even if you really didn't know where you were going, a sensible thing to do now would be to say, well, okay, let's work out an expression for the volume. So this is a prism. It's a prism because it's this sector shape, and then it's extended down, so it's like a sort of sector shaped sausage. So it's the area of the cross section, so that's the area of the end, which we said was r squared over 2. So it's r squared over 2 times the length of the prism, which is h. So I'm going to write that as h r squared over 2. But hang on, they've told us the volume is 300, so h r squared over 2 equals 300. Now, we've got this, and we've got this, and we're going to put them together and hope they turn into this thing. So I'm going to rearrange this for h. So hr squared is equal to 600, and h is equal to 600 over r squared. So now we're going to substitute back in. So s is equal to r squared plus 3 times, and we're going to keep the r, and now we're substituting for the h, so it's 600 over r squared. And you can see that's going to cancel with that. 3 times 600 is 1800, so we've got r squared plus 1800 over r. We have shown that that's the surface area of the box. Now, I've obviously not laid it out very clearly because I've been using a small screen and trying to keep it all in view along with the diagram. So when you lay this out, just try and bear in mind what you're doing is you're writing a story. You're writing the story of how you turn the information in the diagram into this thing. So try and keep it as clear as possible. Part B. Use calculus, so that means integrating or differentiating, to find the value of r for which s is stationary. So stationary points. And that should trigger a memory. Stationary points have the gradient equals 0. But we don't have x and y here, we've got s and r. So ds by dr equals, so we're going to differentiate this. So first of all, as usual, I'm just going to rewrite this in a more convenient form for differentiating. So we've got 2r minus 1800 r to the minus 2, and that equals 0, so we've got 2r minus 1800 over r squared. I've just taken that back into fractional form, equals 0. And then we just rearrange this to solve it. So I'm going to, what should we do? We'll multiply through by r squared. So we've got 2r cubed minus 1800 is 0, which means that 2r cubed is equal to 1800. R cubed is equal to 900, which means r is the cube root of 900. That's not going to be a pleasant number. R is, and using my calculator briefly, 9.7 or thereabouts. Okay, so that's our value of r, for which it's stationary. Now, what's the next bit? Prove this value gives a minimum value. Okay, so minimum, so we've obviously got maximum, minimum and turning points. So there's two ways of doing this. We could use the table, or we can use the second derivative, so ds by dr squared. That would have to be greater than 0 for a minimum value. And greater than 0 means that the gradient is increasing, and that's what happens on a minimum on the graph. If you look at it, you've got a negative gradient, and then the gradient goes to 0, so it's got bigger because it's gone from negative to 0, and now it's gone from 0 to positive, so it's increasing. So when you go round a curve that's on a minimum, the gradient increases because it starts negative and gets positive. Obviously the opposite is true for maximum. So we're going to work out the second derivative, so d2s by dr squared. So just remind you what I'm using here. I'm using this thing here, and I'm going to differentiate it again, and that's going to give me 2 plus 3600 r to the minus 3. So let's just write it down. 2 plus 3600 times r to the minus 3. So just again, I've just differentiated that. Now, when r equals 9.7, d2s by dr squared equals, well, we don't actually have to work it out. All we're interested in knowing is it positive or negative. So let's just rephrase it so you can see what this looks like. 3600 divided by r cubed. Now, if r is positive, then this is positive, and so a positive divided by positive is a positive, so this whole thing is going to be positive, which is what we wanted to know. It's greater than 0. So, greater than 0, therefore, the point is a minima. Brilliant. And now the final thing to do, find the nearest square centimetre of this minimum value of s. So we know that r is equal to 9.7, and going right back to the very beginning, we want to know what s is, and s comes from this formula here that they gave us. So r squared plus 1800 over r. So s equals r squared plus 1800 over r, and so we substitute, so we've got 9.7 squared plus 1800 over 9.7, and that will give us 297.7. And I might be tempted to stop there, but I'm just being really paranoid. What did they want to the nearest square centimetre? So I've got to round it, so it's going to be 280 square centimetres, and that's my final answer. So, bit of an interesting question that uses an awful lot of maths, and of course that's what makes A-level and AS a little bit more difficult, is the fact that you need to use all of these things fluently to get yourself to a solution. Hope you found it helpful. See you soon.